Okay, we're going to have a look at some more examples of multiple roots. So reminder, double root if the polynomial equals to 0 for x equal a, and p dash at x equal a equals 0, but p double dash of a does not equal 0, because otherwise you'd have a triple root, and so forth. Okay, let's do examples. Okay, so we're up to page 29. Okay. Alright. What's nice about these questions is that they often tell you that it has a multiple root. Okay, so show that that polynomial has a multiple 0. Okay, that guides us that we're going to have to differentiate and so forth. Find this 0 and its multiplicity and factorize p of x. Okay, now if I'm looking to solve this or find factors of this, we always look at plus minus the constant term. So to be honest, we'll look for a solution. We'll test p of 1. We'll see if that equals to 0, and we'll also test the plus minus factor, so negative 1 as well. If we sub in, we get 1 to the power of 4 minus 2 times 1 cubed plus 2 times 1 minus 1. Or that just simply, if you work that out, that becomes 0. Okay, so therefore x minus 1 is a factor. Nice. If you sub in negative 1, you get negative 1 to the power of 4 minus 3 times negative 1 cubed plus 2 times negative 1 minus 1. That becomes 1. That becomes positive 2. That becomes minus 2. That becomes 1. That's also 0. Okay, so we know we've got zeros of 1 and negative 1, which means that we've got a factor of x minus 1. And we've got an x plus 1 factor here. Okay, so now we know there's one of these will be a multiple, either 1 or negative 1 will be a multiple 0. So I'll just say x equal 1, 0. X equal negative 1, 0. To determine which one it is, we're going to differentiate and then sub in. Okay, so let's find that we'll do the derivative of p of x. So 4x cubed minus, that'll be 6x squared plus 2. So that's the derivative. We're going to test. So let's test p dash of 1. So it's going to be 4 minus 6 plus 2 if we sub in x as 1. And yes, that does equal to 0. So 1 is definitely a multiple 0. Let's test p dash of negative 1. That's going to be, if we sub in negative 1 there, 4 negative 1 cubed minus 6 negative 1 squared plus 2. That's going to be negative 4 minus 6 plus 2, which equals to negative 8, which doesn't equal to 0. So therefore we found the multiple 0. The multiple 0 is x equal 1. We want to find its multiplicity, so we still need to keep going until we get a p dash that doesn't equal to 0. So let's work out p double dash. So going back to p dash here, and we're going to differentiate this line here. We've got 12x squared minus 12x. Okay, we're going to test p double dash of 1. Only need to test 1 now. Negative 1's gone. Okay, so subbing in there, and I think you can quickly see that that will equal to 0. Okay, excellent. Now let's work out p triple dash. P triple dash x. That's going to be 24x minus 12. Okay, we're going to test p triple dash x. We're going to sub in 1. P triple dash 1. That's going to be 24 times 1 minus 12. That equals to 12, which doesn't equal to 0. Okay. So, working backwards, x equal 1 will be a single root of p double dash. It'll be a double root of p dash, and it'll have to be a triple root of p. I'll say that again. The first one where it equals to 0, that tells me the single root. So x equal 1 is a single root of p double dash. It's a double root of p dash. It'll be a triple root of p. So since p of 1 equals to p dash of 1, which equals to p double dash of 1, which equals to 0, and p triple dash of 1 does not equal to 0, x equals 1 is a triple 0 of p of x. So let's just see, find this 0, x equal 1, its multiplicity, which is 3. That's the multiplicity there. Okay, and then it says to factorize p of x. Okay, so because I know that x plus a is a single factor, and I know that x plus 1 is a single factor, and I know x minus 1 is a triple factor, I've already essentially worked out how to factorize it. Okay, it must take the form of p of x is equal to a, and then x minus 1 to the power of 3, x plus 1. And because it's monic, the a value will equal 1. Okay, so p of x will just be x minus 1 all cubed, x plus 1. And you could have jumped straight to that if you wanted to. Okay. Alright, let's push on page 30. Alright, we've got a polynomial here. I'm going to call this this guy here p of x, if that's alright. We've got it equal to 0 is known to have a double integral root. The word integral, it's a bit of an old school word, but it means integer. So integers are the positive and negative whole numbers, and it's a double root. See, these questions often tell you information if it's a multiple root. Okay, and he says find the value of k. Okay, so because I know that there is a double root, I know that if I differentiate p and set that equals to 0, it should be singular it should be a single root for that. So let's go p dash x, let's differentiate this guy, 3x squared minus 10x plus 7. Okay, so I'm going to set that equal to 0, and I'm searching for potential double roots. Now this guy does factorize nicely. If you times front by back, product of 21, sum of negative 10, we can split the middle term into negative 3x and negative 7x. Group in pairs. Okay, so we get 3x minus 7, x minus 1. Okay, so solving this will be x is 7 on 3, or this guy here will be x equal 1. Okay, now we know it's a double root, and we know it must be an integer, so we need to reject this guy as not an integer. So that means it has to be x equals 1, but we're still going to test. Okay, because the double integer root, if it's at x equal a, it means that p of a equals to 0 and p dash of a equals to 0. Obviously p double dash will not equal to 0, but because I know it's a double integer, I know I'm just going to check this. So I'm just going to test p of 1. So let's sub in, actually, there's a k there, so I need p of 1 to equal to 0, and that's how I'm going to work out k. That's probably, so I need p of 1 to equal to 0. Okay, so let's sub in p of 1, and this will be how we're going to work out k. So 1 cubed minus 5 times 1 squared plus 7 times 1 plus k must equal to 0. So that's 1 minus 5 plus 7 plus k equals to 0. So that's going to be 8 minus 5, 3, plus k is equal to 0. K is equal to negative 3. Okay, so I've done part A. I've found the value of k. I might add here x equal 1 must be a double root of p of x. Okay, B, factorize that polynomial fully. Okay, so you got two options, right? So we know that x equals 1 is a double root, so we know that we can write our polynomial in the form x minus 1 squared, and that's cubic, so therefore we need an ax plus b term here, and you can quickly work out what a and b must be. That's method 1. I might just quickly do it. Method 1. Okay, so because it's a monic polynomial here, a will have to equal to 1, because the leading term is 1. The leading coefficient's 1, and this leading coefficient's a, so a must equal 1. The constant term is k, which is negative 3, and the constant term here, if you square negative 1, you get positive 1, so b must equal to negative 3, so that means that p of x must equal to x minus 1 all squared and x minus 3. The other method would be use sum of roots is equal to minus b on a. So the roots we know that 1 is a double root, and we don't know the other value. Okay, so we'll go 1 plus 1 plus alpha equals to minus b over a, which is going to be negative of negative 5 on 1. Okay, which is alpha is equal to 3, so therefore 3 is a solution, so x minus 3 is a factor. Okay, so therefore you would get p of x is equal to some constant x minus a all squared, x minus 3, and because it's monic, a will equal 1. And we get our polynomial. Alright, I might just